Thank you. Today I discuss about the use of ammonia. Ammonia, it is the industrially ammonia is used for the production of nitric acid by Oswald process, and secondly production of sodium carbonate by sulfate process. And these two are the very important substance in our chemical laboratory. Large amount of ammonia is used for production of fertilizers. Which fertilizers? The fertilizers urea, ammonia, ammonium phosphate, ammonium sulfate, and ammonium nitrate. Out of these four, urea is the organic fertilizer. Now the third one, evaporation of liquid ammonia is associated with absorption of heat from the surroundings, and so it is used as the refrigerant. That means when liquid ammonia is allowed to evaporate, then it absorbs latent heat from the surroundings, and a cooling effect is produced in the surroundings, and this property is used here. And ammonia is used as a refrigerant in the cold storage. Now the liquid ammonia has remarkable solvent property, so it is used as a solvent in our chemical laboratory. It is a solvent. That means liquid ammonia is a solvent. Now the fifth point, its aqueous solution, which is known as ammonium hydroxide, is used widely as a reagent in laboratory. So ammonia is very important chemical in the industry and as well as in our chemical laboratory. Now some precautions to be taken to combat the effect of ammonia leakage, because of in industry or our chemical laboratory we handle the ammonia. So if there is any leakage, then what has to be done? If accidentally ammonia is leaked, must be eyes and mouth must be washed rapidly with normal water, and face should be covered with the wet handkerchief or wet piece of cloth, because of ammonia is soluble in water. So when you wash our eyes and mouth, then the ammonia which is goes to our eyes or mouth, they will be soluble in water. And also the spraying of water in the site of the leakage is also recommended for the purpose. So these are the procedure how you handle the leakage of ammonia. That means the water is used to dissolve ammonia. Now the ammonia gas, how we prepare ammonia gas in industry, because ammonia is the very essential in our laboratory or in the industry. So industrially ammonia is synthesized from its constituent elements nitrogen and hydrogen, and the process is known as Haber's process. And in this Haber's process, the reaction is carried out at about of 550 degree centigrade temperature, but that means at a moderate or high temperature, and at a pressure of 200 atmospheric pressure. And in this reaction or in this process, iron is present as a catalyst, and molybdenum or aluminium oxide is used as a promoter of the catalyst iron. So here 1 volume of nitrogen reacts with 3 volume of hydrogen at 550 degree centigrade temperature at 200 atmospheric pressure in presence of iron as a catalyst and molybdenum as promoter. Then we get the ammonia gas and with heat. And this reaction is the reversible reaction. This is the sign for reversible reaction. And in this process, we must be use the dry nitrogen and hydrogen in the ratio 1:3. 1:3. Nitrogen is 1 volume and hydrogen will be 3 volume. Now a flow chart how the ammonia gas is formed in the industry. Follow this flow chart. Here the dry ammonia in 1 volume and the dry hydrogen in 3 volume. First this mixture is sent to the compression chamber where the pressure is near about 200 atmospheric pressure. This compressed mixture of gas is now sent to the another chamber which is known as the electrically heated catalytic chamber, where the temperature is maintained near about 550 degree centigrade temperature. Here the originally the reaction nitrogen plus hydrogen gives to ammonia. This reaction takes place. After producing ammonia gas, it is transferred to the another chamber which is known as the condenser with cooling pipes. Here the ammonia gas is cooled and transferred into the liquid ammonia, and from this chamber we collect liquid ammonia. As this reaction is the reversible reaction, so some amount of nitrogen and hydrogen remains uncombined. This nitrogen and hydrogen, this uncombined nitrogen and hydrogen is feedback to the compression chamber again. This is the flow chart of the preparation of ammonia gas in Haber's process. Now the manufacture of urea, that means how you prepare urea fertilizer from ammonia. Urea, it is the first organic compound which is synthesized or which was produced in laboratory at first. Urea is prepared by reaction between the ammonia gas and carbon dioxide gas at elevated temperature. Elevated temperature means at the higher temperature and at higher pressure. This reaction takes place in 2 steps, not in the single steps. This reaction takes place at the 2 steps. At the first steps, carbon dioxide reacts with ammonia gas and form ammonium carbamate. Here the ammonia gas reacts with carbon dioxide and forms, this is the ammonium carbamate, NH2COO NH4. In the second step or the next step, this ammonium carbamate decomposes into urea and water. In the second step, ammonium carbamate decomposes into the urea and water. This is the ammonium carbamate. From this ammonium carbamate, 2 hydrogen from here and 1 oxygen from here, it comes out and forms water. and here it is remain NH2CO NH2, that means CO NH2 whole 2, and it is the ammonia. So this is the process how you prepare or how industrially it is urea is prepared. Thank you.